Hello everyone, welcome to Menta. My name is Pranay Sharma and I'll be your lecturer for this term. The topic that we'll be taking into our consideration today is trigonometry. So the prerequisite for this particular topic is, I'm assuming that yes, you must be well aware of what congruence is and what exactly do we understand by similarity. Because these are the concepts that we'll be using, and this is going to be an introductory session. So in case if you find something difficult, then it is completely all right because this is something that you are starting it for the very first time. Trigonometry is something that gets introduced in 10th in CBSE, and then later on, it will be there for some time, and it will also be there in engineering in case if you are opting for mathematics in your grade 11th, right? Let us get this started. Okay, this is going to be the learning outcome. That means by the end of this session, what you will be able to define. So you'll be able to define trigonometric ratios. Along with it, a lot more. Why we are using trigonometry? Why do we need to introduce other ratios along with contribution? Why we are having this as a separate branch of mathematics while we can get some problems solved easily with the help of normal what we say modulation, right? So let us see what trigonometry is and how we can approach the timed limitations related to trigonometry and where do we exactly use it, what type of triangle is actually going to fit under the frame. That is something that is the most common doubt that I am getting over my mail. People used to ask that where do we use trigonometry, is it only restricted to right angle triangles? So for your grade it is restricted to right angle triangles, but it is not. You can apply trigonometry in other triangles as well in terms of law of sines and law of cosines that we'll see when you actually start for IIT JEE preparation, right? All right. So let me bifurcate this word. Trigonometry is bifurcated into two halves, trigono and metry, right? Word trigono means trigon, which means triangle. That means something that is composed of three sides. That is nothing but triangle. Metry gives you metron, which is nothing but measurement. That means something that is related to triangle measurement that comes under trigonometry. So one thing is for sure that wherever we have triangles, we'll be using it. But sir, do we use it in circular reference as well? So that is something that I am leaving for this particular session. We'll give you an explanation in next session for this. This is just an introductory class. I just want you to get through with what trigonometry is, and then we'll be able to progress further on this. So measurements related to triangles comes under trigonometry. All right, so we are given with an interesting question, which is, can you find the height of a tree without actually climbing it? Now that is the question, right? Everything is given to you, and whatever is given in this image, that is considered as true and up to the optimum. That means this is the available data with us, and we need to calculate the height of this tree. How can we calculate this? Now that is the question. We need to have certain measurements as well. But before than this, let me jump to whiteboard in order to give you a contextual clarity of what exactly similarity is. I hope you people are very much equipped with what congruence is. Let us take one example. Okay, I don't have enough items available for me to explain you what. Okay, I have. Just a second. I hope my screen is visible. That means where you are able to see PIP, or that means your teacher's aid or teacher's side. That is visible and it is correct, right? Okay. So I am having one object with me. All right. Another object which is of same shape and same size is available to me. Now, if I'll try to superimpose both of them, right? So clearly, this particular box is able to hide the next box that I have appended at the back, right? So if that is the case that we have, then we call this as congruent, right? Two things are said to be congruent when they are equal in dimension, same shape and same size. But what if we have same shape but not same size? Let us see that particular part as well. For that, I need to jump to whiteboard. I hope my screen is visible. Okay, so let us jump to shapes. I don't think we have the shape that we actually want it to be. It is not available. So we have to have a setup. Sometimes, we need to have few drawings, and because of this, it may take some time because I'm not that good. Okay, so if I'll erase this entire shape will be gone. Okay, fine. So we'll keep this intact. Let us say this is A, B, C. All right. So ABC is a right angle triangle wherein we have right angle at B. And we have this angle as theta. Theta is an acute angle. The acute angle is lesser than 90 degrees. Okay. What about this angle? Can we say this will be 90 minus theta? Now we don't know whether AB and BC they are equal. If they are equal, then this angle A will also be angle BAC will also be theta, right? But we don't know this. So we'll keep this intact. Now suppose we have another triangle, right? Let me have this with the help of different marker. Although things are not, the way they were planned to be. All right, let us call this as DEF. Right? This is angle 90 and this is theta. See, theta is same. That means we can say angle BCA equals angle EFD. All right, both are equal to theta. But the sides is different. Angle D, sorry, triangle DEF is is smaller than triangle ABC. But they have equal angles, right? Not if we talk about this angle D, don't you think this will also be 90 minus theta? As this is 90 minus theta. So if all the angles are same, right? Same angles, not sides, same angles, right? Then we can say that yes, they are similar. I'm not concerned about their sides length. Their sides lengths are going to be proportional. This is something that you have already studied in grade 9. So I'm just giving you an in-text and an overview what it is, right? So there, if two triangles are set, if they are similar, then their angles are equal and their sides are proportional. That is what, the depiction that we can draw from this. Fine. So let us jump back to our slides again. Let us see. So I'm leaving this question as of now. We'll be, discussing this question in great detail. Once we'll be again, exploring this topic, the similarity topic. Okay, let me jump to whiteboard and I'll tell you how these are similar. We have a criteria. See, angle ABC equals angle. Okay, I'll be using a different marker so that contextual clarity will always be retained. If I want to establish a relation between these two triangles, that they are similar, how will I do this? I'll say that angle ABC equals angle DEF, both being equal to 90 degree. This is something related to an angle. Next is angle ACB equals angle DFE equals theta, right? This is something that we have presumed. This is again an angle. So we can say by angle criteria of similarity, triangle ABC is similar to triangle DEF. This is a sign for similarity. All right. Let us jump back to our slides now. I hope the slides are visible. So the question is why we have appended this slide. So first I'll be putting multiple questions and then I'll be answering them one by one. So first question is this, can we find the height of tree without climbing it? Yes, I'll tell you how. All right, how we can have this. Using similarity of triangles, we can get this established. Next is, where do we use trigonometry? We'll be using trigonometry in navigations. Most of you are, using Google Maps, Pata app. So this is, and nowadays we have a recent introduction in Ola, right? Ola is not using Google Maps. They are having something of their own. So that comes under indigenization. Right. We can also estimate very large distances, the distances in outer space. Navigation, so if it is navigation, be it on water or on street, it will make sense, right? Navigation will remain the same. In this long boats and ships, you will need navigation. In an airplane, again, navigation is needed. So we are considering right angle triangle, wherein, we have right angle at C and angle B is theta. All right. Now, what we have done here in this, we have extended this length. That means BC of triangle ABC to E. That means now we have one complete length as BE. And similarly, we have extended BA to D. So now we have a complete length, which is BD. All right. Now, if you go with an exploration, you will be able to find two different triangles, right? Triangle ABC and triangle DBE. See, this is triangle ABC, okay, ABC and triangle DBE. I hope the cursor is also visible. Let me see if I can turn on anything. Okay, so I can turn on pen. So triangle ABC and triangle DBE. All right. Both of them are similar. Why? Because this angle is also 90 degree. This is also 90 degree. So we can say that triangle ABC and triangle DBE, angle C and angle E, they both are equal. They both are equal to 90 degree. All right. This is angle C and this is angle E. Next is we have angle B as common. All right. So we can say that by angle criteria, these two triangles are similar. So if these two triangles are similar, their sides are proportional. So if I'll take AC, then I'll be taking DE of this particular side, right? And if I'll take BC, then I'll be taking uh, BE, this side, right? So if you interchange them, right, that means if you keep AC here and instead of this DE, if you shift this DE to other side, BC will come down. So it will be AC over BC equals DE over BE. All right. That is nothing but this. I hope this is clear. So we'll move to next slide. But if you change this B is not going to be the same, right? If you have elevated it, then obviously you will not be you will not be getting this AC over BC equals FC over BC, right? That is something that is a proven fact because these two are not similar at all. So that means it depends on theta. It depends on one more angle. We have followed AA criteria and that is how it goes, right? So they have proved it using AA criteria that sides are proportional if two triangles are similar. That is where we get this AC over BC equals DE over BE. All right. Now let us jump back to our initial example that we initially considered. And I'll only be giving you sides ratio for this particular session. In next session, we'll be exploring them. Where do we actually use it? So this is our very first question. How do we calculate the height of tree without climbing it? So we know that if suppose sun is somewhere here, let me have marker here. Okay, so I'm given with limited colors. So let us use green only. Suppose we have a sun here, right? As I have only green, so that is why I am making it in green. Other than this, we do have a different setup for this, but yes, I'm only having this, so that is why this is an exception, and this I'm requesting you to please do consider this that yes, it is available with us in green. Fine. We have sun rays, right? And because of this sun rays, this shadow is being formed because sun is somewhere here, right, at this location. So this shadow is being formed. If we calculate the shadow length, right, if we know what exactly the shadow length is, right, and if we know this angle, let us say this angle is theta, then it is very easy for us to calculate the height using trigonometry. But so far, I have not introduced you with sides ratios and its what we say alignment with respect to different angles, right? This is something that I have not given so far. So we'll be using the concept of similarity. We have considered another pole which is on ground having the same angle of elevation, theta, right? However, this height and this length is given to us in the next slide. So this is 4 meter. Okay, let me erase this. This is 4 meter and this is 3 meter. All right. Angle remains the same. See, this angle and this angle, they are one and the same. And this length is also given to you, which is 60 meters. As I told you that if two triangles are similar, this is 90 degree, this is again 90 degree, these two angles are same, so they are similar by AA criteria. So we can say their sides are proportional. That means h by 4 equals 60 by 3, which gives h equals 60 into 4 by 3, 20. 80 is going to be the height, right? Let me erase this. So this is how things goes. Fine. However, you can also use trigonometry in order to get this calculated. But for that, you need to at least know what theta is. So if you know what theta is, it is very easy for you to calculate this. Fine. So let's take a right angle triangle with angle of reference as theta, which is an acute angle, right? So if this is theta, side that is opposite to this angle will be known as opposite. The longest side of this triangle, as this is right angle triangle, side that is opposite to 90 degree will be the hypotenuse. That means this is the longest side. And as this side is adjacent to theta, so this will be known as adjacent side. Let us move to next slide, which gives us the relationship between theta, their sides, and a function, a trigonometric function. What do we call that? Now, suppose if I'll say that I need to take opposite over hypotenuse ratio along with theta. So this particular thing in mathematics has a different function. We need to have a different function, and that function is known as sine. Now, this is not like that sine is getting multiplied with theta. No, it is not the case. Sine is not getting multiplied with theta. This is just a representation or a denotation that we have applied sine of theta, which can be calculated as opposite upon hypotenuse. Cosec is reverse of sine. That means whatever we have done here, you need to reciprocate it. So if you reciprocate it, numerator will become denominator and denominator will become numerator. That means it will become opposite upon hypotenuse. That is nothing but cosec theta. Right? We are also writing it as CSC theta. This is also a denotation in which this can be expressed. The full form of this is SINE, sine. This is cosine. Sorry, this is cosec. Let me erase this. Okay, let me discuss sine, cosine, and tangent first, and then we'll be moving to their reciprocals. Cosecant, secant, cotangent. Okay, so that means this is sine. We have taken opposite upon hypotenuse, right? Along with theta. So we have a different function here, which is sine of theta. That means whenever we are taking opposite upon hypotenuse, that will give us sine of theta as a function in itself. If we reverse this particular ratio, particular what we say P over Q form, then we'll get hypotenuse upon opposite, which is nothing but cosecant of theta. Similarly, we have cos theta when we have adjacent upon hypotenuse, right? and secant is reverse of cos, right? So how do we learn this, and how do we remember all this stuff? So let us jump to our slides again. We'll take the same example, this example, right? Let us call this as hypotenuse, this as base, and this as perpendicular. Perpendicular is the height. However, this BC can also be treated as perpendicular. Let me draw it again, because it is, you know, looking a little bit clumsy, and I don't want things to get distorted. Hmm. So this is A, B, C. The longest side, as we are assuming that 90 degree is somewhere here, right, over B. So this will be hypotenuse, this will be base, and this will be perpendicular. Fine. Let us say this angle is theta. Now, if suppose somebody is asking you to calculate sine theta, right? How do you actually remember all this, denotations and demography? So we have a simple trick for this, although this trick is something that few authors, they have mentioned it, but you will not be finding it available in authentic textbooks. So let us write P, B, P. And how do you remember this? This can be remembered using Pandit. I'm having one word with me, or rather, I should say a sentence in which this can be remembered. Pandit Badri, P stands for Prasad. So this is a name, Pandit Badri Prasad. And as he is Pandit, so he's chanting her bhole. Right. So this H stands for her bhole. Fine. So if you take ratio of P over H, that means perpendicular upon hypotenuse, this will give you what sine. If you take ratio of B over H, sine of theta, rather I should say, B over H will give you cosine of theta, and P over B will give you tan of theta. Now, if you reciprocate them, this will become cosec theta, this will become sec theta, and this will become cot theta. I hope it is clear. So I'm rewriting it here. Sine theta is what? P over H. Cos theta is what? B over H. Tan theta is what? P over B. Right? Cosec theta is what? H over B. Sec theta is what? H over B. And cot theta is B over B. Now, if you carefully observe, the reciprocal of this is this. That means if you multiply sine and cosec, you'll get 1. Let us try this. So I'm multiplying sine theta into cosec theta. Let us see what I'll get, which is nothing but P over H into H over P. This will go away, we'll get 1. Right? So let us move to our slides now. Probably this is going to be the last slide. I hope this particular part is clear. But sir, here we are given with different understanding, opposite, adjacent, and hypotenuse. I told you how to figure out hypotenuse. Side that is opposite to 90 degree will always be hypotenuse. Now, for opposite and adjacent, you need to check the theta from which you are, taking your reference. So suppose if your theta is somewhere at B, so side that is opposite to theta will be opposite, and side that is in attachment with B should be adjacent. This can be remembered using SOHCAHTOA. All right, that we'll discuss in next class. However, for better understanding, you can go with Pandit Badri Prasad and Harar Bole. That will work good. So this is something that comes under reciprocal relations. I told you what they are. Sine into cosec will give you 1. Similarly, cos into secant will give you 1, because both are reciprocal of one another. Fine. Tan and cotangent again 1. So I'm concluding this session. Thank you so much for joining. In case if you have any doubt, you can let me know, and we'll be taking your doubts in next session. Next session is going to be interesting for trigonometry because whatever we have covered so far will be having a practical implications of this particular topic. I'll again be, revisiting few of the fundamentals that probably you have missed in ninth grade. So we'll be reconsidering them. This is the most important chapter because it will be there in 11th physics, 12th physics, right? If you are preparing for IIT, it will be there. And in fact, if you go for NWT, again, you will be, getting physics. And physics can only be solved using this, right? The higher grade mathematics and physics I am talking about. And these two subjects are interrelated and they are only be solved using trigonometry. So we have a lot more to go. And if your base is strong, then definitely it will give you fructifying results in near future. Thank you so much.